So I thought I'd just remind you all a little of the anatomy of the ear. I'm sorry I haven't got a pointer, but you should know that there's a bony shell inside your ear which contains both the vestibular apparatus and the cochlea. And this is a picture which is available on the net. I think that's from a book. I've got to be a bit careful. Inside that bony shell, we've got this delicate membranous labyrinth. It's like a balloon, if you like, that has the cochlea, the saccule, utricle, and the 3 semicircular canals. And that's full of substance called endolymph. And what happens in Menieres is that we've found that people have that balloon, that membranous labyrinth, is blown out, and it's called endolymphatic hydrops. And this shows a picture on the right from histology with the scala media, which is where the endolymph is blown out. And you can see at the bottom a little diagram. So this was my diagram of that balloon, the membranous labyrinth. And we have the cochlea on one side, saccule, the 3 semicircular canals, the utricle, and then the duct leading to the endolymphatic sac. People said that originally they thought it was an IUD, but I promise you it's meant to be just a cartoon drawing of the inner membranous labyrinth. And what we know is that there are various sections to it. There's the endolymphatic sac, which in man, about a third of it is within the bone, so it fuses in with the duct. Then we have the endolymphatic duct, which is incredibly narrow. Then we have the sinus, the endolymphatic sinus. Then we have the valve of Bast. Then we have the saccule. So you may ask yourself, why did God make it so complicated? It is, and I can tell you there's good reason why he did it. He knows everything. So what we know is that the most compliant or easily distended part of the ear is the apex of the cochlea. So if you get a little bit of extra fluid in the ear, the bit that blows out is the apex of the ear, which I've represented in blue, just to show where the hydrops is. So in Menieres disease, the first place that gets endolymphatic hydrops is the apex of the ear. Hence, we get the low frequency hearing loss that fluctuates depending on how much fluid is present. Unfortunately, eventually in Menieres disease, the whole ear will get blown out eventually, and the whole ear is affected by endolymphatic hydrops. So what we know is the endolymphatic sac is a very important structure. It's the only structure really that can remove excess endolymph. So you have too much endolymph, it has to be removed by the endolymphatic sac. It's immunologically competent. So it contains different things, macrophages, plasma cells, etc., that can destroy and remove viruses. Its job is to defend irreplaceable structures in the cochlea. So if a virus gets into the ear and it goes into one of the hair cells, then killer cells will come, it'll replicate the nucleus and then killer cells and it destroy those hair cells. So we don't want the hair cells that you hear with or balance with being destroyed. So the endolymphatic sac has a role in protecting the cochlea and the vestibular system. And controversially, so I put it in blue because it's just my own idea, it can signal the cochlea to make extra endolymph to flush noxious materials out of the inner ear. So if there's something in the inner ear, the sac can help signal to it, get more fluid into the ear and get rid of that fluid. So normally, and we know this from Alex Salt in the States, the fluid in the ear doesn't drain anywhere. It's just regulated by the blood vessels in the ear. So if an inflammatory reaction occurs inside the ear, and Dan's been doing this with some stuff he can inject into the endolymph, then the viruses or whatever lying inside the cochlea, then what happens is that we produce some hydrops, or hydrops is produced by the inflammatory reaction, and then it's drained into the sac. That fluid will move into the sac, removing all those noxious and horrible materials to the endolymphatic sac, where they can be neutralized and removed. So this is a very old theory of mine, which is still in dispute, but we formed it in 1991, that it was reflux of endolymph from the cochlea into the utricle during episodes of longitudinal drainage, which caused the attacks of vertigo. So what we're saying is that in Menieres disease, the endolymphatic duct is contained in quite a tight bony canal. And when you get fluid in the, when the fluid tries to drain out of the ear, it can't get through very easily. It fills up the sinus and eventually blows back into the utricle, stretching the crista of the balance canals and causing the attack. So that's the theory. And then once it's drained, the hydrops is virtually gone, but unfortunately in Menieres, some hydrops will remain in the cochlea and also in the vestibule. So then once you've got hydrops in the ear, little events that can cause a slight increase in the fluid in the ear might be enough to trip the longitudinal drainage mechanism, or at least make it drain again. So it could be eating a salty Chinese meal. It could be stress when your daughter gets her Visa card. But all these things might just increase the fluid enough to cause another attack until it's drained down enough that you get a period of remission. So you have one attack, then you may have a series, then you have a period where it goes away. And we've got some backup of this idea from Dan and the lab, because they've been injecting things into the ear, and they can see that we're not getting ruptures in the ear, and that when they inject into the utricle, you do get changes in vestibular function. So that's some of the lab work. Now, we've known for years, and there's so many papers on this, I've only thrown one up, which is from Japan, that there are viruses have been found in the endolymphatic sac. And there's a lot of people who, like Gajcek and others, that feel that Menieres is a viral condition. So the cause of Menieres disease? No. The causes of Menieres disease, there's probably many different routes that end up causing Menieres disease, but the one we're interested in for this study is going to be whether it could be a virus or not that is the cause of the Menieres disease. So what we're saying is that a viral labyrinthitis, like in an ear with a narrow aqueduct, ends up with the formation of endolymphatic hydrops. So for some reason, there's a problem removing that excess fluid and all the antigens, that's the products of the virus, into the endolymphatic sac. Can be structural, it could be a genetic deficiency, or it could be an immunological deficiency. And Stephen Spring's here, and he knows much more about the possibilities of the immunological deficiency than I do. And then you end up with the chronic hydrops. So the small fluctuations in the level of endolymph sufficient to activate longitudinal drainage and cause the attacks, until the volume of endolymph drops below a critical level, and then you get a nice period of remission. So what's the cause of the recurrence? After a nice period, you think, good, it's gone away. We've had several weeks, months without it. Now it's come back. So either the virus has re-erupted within the cochlea, and we all know cold sores, for instance, that can re-erupt on the face, or an antigen, which is a structure of the virus, is blood-borne to the endolymphatic sac, and the endolymphatic sac then steps into action to ensure there's nothing harmful inside the cochlea. So this bottom one should be in blue. That's very theoretical. And the endolymphatic sac activates a mechanism to increase the endolymph in the ear and then to flush it out of the cochlea to protect the irreplaceable structures in the cochlea. Oh, come on, move. Page down. Not moving. Sorry. Then what I want to go to next is to tell you the study that we want to do to prove whether or not, oh, well done, thanks. So we want to do a study to find out whether viruses can be involved in Meniere's disease. And we need volunteers, okay, or participants. We thought we'd better choose people who had Meniere's between the age of 30 and 70, because some of the younger people are more likely to have other things that could happen, like congenital things. That it should start with a nasty attack. The first attack should be a nasty attack, and they're still getting the attacks of vertigo. Then we have to find people who are willing to go to their local Douglas Hanley Moir, the blood people, and have a blood sample taken as soon as possible. I don't want people falling over or being run over by motor cars, but as soon as it's safe to get there, and they will take the blood and they'll treat it in a special container to send it to the University of Sydney, where virologists will check to see if we can find antibodies or viral particles in the blood. And then, because we're saying it has re-erupted during an attack, we want another sample a few weeks later when they're well, when they've gone into remission, so we can compare how much virus or antigen is present. And that would help us know what's going on. So we hope to be able to keep the volunteers informed. We'll let them know if we find any viruses in their blood, and we'll also let them know the outcome of our study. So first of all, we have to receive the name and address of potential volunteers. Then we're going to mail out or give you some more detailed information and the consent forms, which must be signed. On receiving the consent forms, we contact them. We ring them up. It'll either be Payal or myself. There's the three, and Daniel, we're the three that are the chief investigators. And then we ask them the questions, but the questions will be on the form that's sent out, so they'll know what questions we're going to ask. And then nothing then happens until they have an attack. Then on receipt of the first specimen of blood, we send out another form.
Any exclusions in relationship to comorbidities or current medical regimes like antivirals?
Yeah, well, if you're on an immunosuppressant, such as steroids, or you've got really bad rheumatoid arthritis, then that might spoil the study for us. So that is in our more detailed handout. I'm just giving you the basis of the study first. And then we thank them, tell them that we'll let them know the outcome of the study. So if successful, can we cure Meniere's disease? Well, we're just wondering if we could boost the circulating antibodies to that virus, if we find it, that the virus can then be destroyed in the circulation rather than reaching the endolymphatic sac or cochlea in sufficient levels to cause an increase in their endolymphatic hydrops. Now, I'm sorry that I may be very complicated. I try to keep it simple, but we are doing a live webcast, and if anybody wants to, we'll hand out this number. You can click on it, and you can go through any of the talks today if you want to hear or need to go into them in more detail. So thank you for listening to me. Now the bit you're probably most interested in is Dan's going to come up, and he's head of the laboratory, and he's going to tell us some of the new things that have come out of the lab which we definitely need to chase up in the future.